We're now on to the final case study of the course, learning to detect emotion in images. In this section, we'll be looking at emotions in images. We start with an overall description of the problem. Next comes obtaining and working with the dataset of interest. Finally, we will train an algorithm to detect emotions in images. Let's dive right in. In this video, I describe our problem, how we frame it, and how it's approached. Here is an overall description of detecting emotion. We will start with an image of a person with their face. One pre-processing step we may take is converting the image to grayscale, if we think that color won't contribute much to our classifier. A major step in the process is detecting the faces in the image. We have already seen approaches to detecting faces, and in this section we will be using a dataset where faces are already the majority of the image, but elsewhere this would be the first big challenge. We feed the pixels in the face subimage of our classifier to predict the emotion of the individual. Emotion here is one of a finite collection of labels corresponding to a common grouping of human emotions. Emotion detection then is ultimately a classification problem. Many classifiers are used for this step, ranging from SVMs and linear discriminant analysis to deep learning methods. In this section, we will be using the local binary patterns histogram, or LBPH classifier for this task. The LBPH algorithm works as follows. First, the algorithm will iterate through pixels in an image, looking at the pixel's neighbors. Next, the algorithm will turn pixels into a binary code depending on whether neighboring pixels are more intense than the central pixel. The binary code is then converted into a number. All the numbers found this way are collected and an image histogram is formed. This histogram is then used to compare images. We've seen how to use image histograms for comparing images before, when we were talking about image search. When trying to detect emotions from images, in addition to the usual problems, we have problems innate to this particular application. First, a finite, discrete grouping of emotions seems artificial and often inappropriate. A continuum seems to describe emotions better, despite human language's desire for discrete groups. Next, it's possible that not all cultures have the same emotional categories and thus may produce different groups. Emotions are highly similar. For example, while happiness may not look like sadness, anger may look like disgust. In general, detecting emotions is a hard and often poorly defined problem. Nevertheless, we will attempt to do so.